Supreetha. Welcome to my math class. So in the previous lectures on Laplace Transform, we studied the definition of Laplace Transform, we solved some problems, yes, and then we solved some direct formulae problems. Yes, in the previous lecture, we saw how to resolve or how to simplify the given trigonometric function. We used some trigonometric formulas and then we applied Laplace Transform. Okay, now in this lecture, let us study how to solve Laplace or how to find the Laplace of the functions. Yes, say I have f of t as something like say e power at into f of t. Yes, what is this? If I ask you to find the Laplace of, yes, e power at into cos at, how would you find it? There is no formula to reduce this to sum of two terms or anything like that. We cannot apply to the product of this. We don't have any direct formula. Agree? Now for this we have a property. We have a property named shifting property. Okay, we use shifting property to solve this. What is the shifting property? Okay, shifting property. What is the shifting property? Firstly, let us recall. Yes, I told you, if we have Laplace of f of t, if we find Laplace of f of t, the result would always be like f of s. We would get in the answer, there will not be t, we will get it s. Yes, that is, the real value is changing to a complex value, that is s. Okay. Now, the shifting property states that, yes, if Laplace of f of t is equal to f of s, then Laplace of e power at f of t is equal to f of s minus a. Okay, what does this mean? Let me try to prove this. Okay, the proof of this would go something like, now let me take this part, yeah, the RHS, that is f of s minus a. Okay, from the definition, yes, from the definition of Laplace, what was f of t? Yeah, what was the definition of Laplace? That was Laplace of f of t, yeah, Laplace of f of t is equal to integral from 0 to infinity e power minus st f of t dt. Okay, now as I told you, we can write this Laplace of f of t as f of s. Okay, now you see here on the RHS we have f of s minus a. So what should I do? Let me replace in this definition, let me replace s with s minus a. Okay, this would be equal to e to the power minus s minus a into t f of t dt. Now let me multiply the negative sign, so I would get 0 to infinity e to the power minus s plus a, yes, into t f of t dt. Okay, again from 0 to infinity e to the power minus st into e to the power at. Bases are the same. If I add the powers, I will get back the previous step. Agree? So I have something like this. Yes, so you see the formulae, observe the formulae and what we've observe the formulae and observe this step. In place of f of t, I have e power at into f of t. Yes, I have e power at into f of t. So what should I do? The LHS would become Laplace of, in place of f of t, I have e power at f of t. So let me write that down. E power at, or this would be like, this is equal to Laplace of e power at f of t. Did we arrive at the LHS? Yeah, we arrived at the LHS. So what does this shifting property say? So basically, shifting property is used to solve problems or to find Laplace of functions when you have the function as in this form. Yes, shifting property is used to find the Laplace of a function which is in this form. Okay, that is e power at into f of t. Let me take a problem now. Okay. Yes, so that is e power minus t into sine 5t. So clearly this is in the form of e power at into some function. So let me apply shifting property. How do you apply shifting property? Firstly, observe and write down what is f of t. Yes, clearly f of t is sine 5t. Okay, this is the first step. What is the second step? You find Laplace of f of t. Okay, what is Laplace of sine 5t? Laplace of sine 5t is 5 divided by s square plus 5 square, that is 25. Okay, now for the last step, Laplace of e power minus t sine 5t would be, you have to replace, yes, you have to replace s with s minus a. Okay, that is, you replace s minus of minus 1. Okay, that would be 5 divided by s plus 1 the whole square plus 25. Yes, so what is the first step in shifting property? The first step is, we have a function in the form of e power at into f of t. Okay, so the first step is, you identify f of t in the given question. Okay, and then find its Laplace. Okay, after finding Laplace, you would get f of s. Agree? So the second step would be, you replace f of s. Yes, wherever you have f of s, replace it with f of s minus a. Yes, replace s with s minus a. So I had s over here. I replaced s with s minus a. I got a plus here because a is already -1. Minus into minus is plus. Okay. Now, moving on, let me take another problem. Yes, find the Laplace transform of, the second one is, find the Laplace transform of e to the power 3t into cos 6t minus sine 4t. Okay, now what should I do here? We have a product, right? Yes, we have a product. So what would I do? Let me just multiply e power 3t cos 6t, yeah, minus e power 3t sine 4t. Yes, if I have to apply Laplace now, I would apply Laplace to each function because I have a negative in the middle. Yeah, minus Laplace of e to the power 3t sine 4t. Okay. Now, firstly, what should I do? Let me solve the first term. Okay. What do you have in the place of f of t? I have cos 6t. Yes. What is Laplace of cos 6t? Laplace of cos 60 is s divided by s square plus 6 square, that is 36. Okay, what is the second step? Replace s with what? S minus a. What do we have in place of a? We have 3. So I'll replace wherever I have s with s minus 3. Yes, s minus 3 the whole square plus 36. Okay, how about the second term? Second term would be, what is Laplace of sine 4t? Laplace of sine 4t is 4 divided by s square plus 16. Now, what is Laplace of e power 3t sine 4t? That would be 4 divided by, wherever you have s, replace it with s minus 3 whole square. Okay, now let me write it down. Yes, I'll write it as, from this step we have this step. Okay, that is s minus 3 divided by, let me apply a plus b whole square, a minus b whole square to this. That would be s square plus 9 minus 6s plus 36, negative sign, 4 divided by the same thing, s square, s square plus 9 minus 6s plus 16. Okay, now what is 36 plus 9? S square minus 6s, that would be plus 45 minus 4 divided by s square minus 6s plus 25. Okay, you can simplify it further by taking LCM. Yes, now moving on to our third question. Okay, our third question is, find the Laplace of e power minus 2t cos hyperbolic 4t. Firstly, in place of f of t, I have what? I have cos hyperbolic 4t. Yes, what is Laplace of f of t now? What is Laplace of cos hyperbolic 4t? Laplace of cos hyperbolic 4t is s divided by s square minus 4 square. What is 4 square? That is 16. Yes, what is the next step? Laplace of e power minus 2t f of t. I can write it as f of t or cos 4t, cos 4t. That would be, wherever you have s, replace it with what? S minus a. In place of a, I have minus 2. So that would be s plus 2. Okay, so let me replace s with s plus 2 divided by s plus 2 the whole square minus 16, s plus 2 divided by s square plus 4s plus 4 minus 16. This is equal to s plus 2 divided by s square plus 4x minus 12. Okay. So yes, moving on to our fourth question, that is, find the Laplace transform of, find the Laplace transform of sine hyperbolic 80, okay, sine hyperbolic 80 into sine 80, okay. Now, how do you solve this? You don't have any trigonometric formulas for this, If you remember, in one of the videos, I told you sine hyperbolic 80 can be replaced as e power 80 minus e power minus 80 divided by 2. Yes, so let me do that. I'll replace, in place of a, I have a itself. So I'll write it as e power 80 minus e power minus 80 divided by 2 into sine 80. Yes, what is e power 80 into sine 80? Okay. Minus e power minus at sine at whole thing divided by 2. Okay. Now if you have to find the Laplace of this, yes, half is a constant. Agree? Let me take that out. Yes, I can give Laplace to each term. Laplace at sine at. Yes. Minus Laplace of e power minus at into sine at. Okay. Now, what is Laplace of e power at sine at? How do you solve it? What is the first step? You replace or you find the Laplace of f of t. What is f of t here? It is sine at. Okay. What is Laplace of sine at? Laplace of sine at is a divided by s square plus a square. Okay, what is the next step? Laplace of e power at f of t. This is equal to, wherever you have s, replace it with what? S minus a. Okay. So if I simplify this, what would I get? I would get a divided by s square minus 2as plus a square plus a square. Okay, now moving on to the second part, that is, let us find Laplace of, yes, Laplace of e power minus at sine at. The same thing, Laplace of sine at is what? Laplace of sine at is a divided by s square plus a square. You replace s with what? S minus of minus a. Why? We have in place of a, we have minus a over here. So I would get what? A divided by s plus a, the whole square, plus a square. Applying a plus b whole square, I would get s square plus 2as plus 2a square. Okay, now let me write that down. Yes, let me substitute these both values in this step. That would be half into a divided by s square minus 2as plus 2a square minus a divided by s square plus 2as plus 2a square. Okay. So yes, we studied something called as shifting property. What is shifting property? If you have a function in the form of e power at into f of t, we apply shifting property. Okay, what do we do in the shifting property? First, you find the Laplace of, okay, we find what? If you have a question in the form of e power at into f of t, we find the Laplace of f of t. Yes, the Laplace of f of t would be something in the form of f of s. Agree, we would get f of s. So in the next step, that is, the next rule is, wherever you have s, replace it with s minus a. Okay. So yes, that is it for today's class. Thank you.